Today we are studying the effects of selection in a population of 1,500 rabbits. In the initial population, when all aspects of the Hardy-Weinberg equilibrium were obeyed, we had 382 rabbits possessing the big A genotype for black fur. There were 369 rabbits with white fur, meaning they would have the little a genotype. There were 749 heterozygous rabbits exhibiting brown fur, a product of having one big A and one little a. The table created here shows the genotypes and their associated individuals. Figuring out the allele frequency will help us to determine the Hardy-Weinberg equation. To find the frequency of the big A allele, we should take the total number of big A alleles and divide that by the total number of alleles. Since there are 382 rabbits with the homozygous big A allele, we must multiply that number by 2 and add the 749 big A's from the heterozygous genotype. After doing this math, we have a big A allele frequency of 0.5043. We can go through these same steps for finding the frequency of the little a allele. The frequency of the little a allele is 0.4957. Now that we have the allele frequencies, we can set up the Hardy-Weinberg equation and chi-square analysis to ensure our initial population is in Hardy-Weinberg equilibrium. We find the p-squared value by squaring the frequency of the big A alleles. This gives us our genotypic frequency for big A, big A. We do the same with Q, square the little a allele frequency to find the genotypic little a frequency. We then multiply the two allele frequencies together and multiply by 2 to get the genotypic frequency for the heterozygote. After getting these values, we can use them to find the expected genotype numbers and finish our chi-square table. We see that our chi-square value is 0.0031, which is less than the critical value, indicating our population is indeed Hardy-Weinberg equilibrium. Our population of rabbits undergoes viability selection, meaning some are more likely to survive and reproduce than others. This is their fitness value. Say our rabbits were living in a darker environment, allowing the black and brown rabbits to camouflage and escape predators better than the white rabbits. So these black and brown rabbits had a higher fitness level. We use these fitness levels to calculate our average fitness level as shown in row 3 of the table here. We can then use the average fitness value to find the genotypic frequencies after selection by dividing in the unadjusted survivors by the average fitness value, as shown in row 4. We can then use these values to find the new allele frequencies. The equation and resulting frequencies are shown in the table below. This problem is indicating directional selection because the fitness values are favoring the genotypes big A, and big A, but not little a. Essentially, every time you add a big A to the genotype, your chances of survival will increase. Over time, this will cause the big A homozygous genotype to be the only one present after an infinite number of generations. These are my references. Thank you.